Welcome, everybody. Thank you for joining today's webinar, Front-End Loading for Control System Migration. This webinar is co-hosted by ISA and Maverick Technologies. My name is Michaela Cooper, and I'm with ISA, and I will be hosting today's webinar. Before we get started, I would like to review a few housekeeping items and let you know how you can participate in today's session. First, in regards to the question and answer session, we have one Q&A session at the end of the webinar. To submit your questions, simply type them into the Q&A box on the right-hand side of your screen. If you're viewing along with others at your site, please designate a scribe to submit your group's questions. If you have a question for a specific presenter, please indicate that in your question. For example, if you had a question for Matt, say, Matt, comma, what did you mean by X? And that'll help us figure out who that question is directed towards. And please do not use the chat toolbox for your questions for the Q&A session. If you have miscellaneous questions for me, the host, submit those into the chat toolbox. But please only use the Q&A chat toolbox for the Q&A session. But you can submit your Q&A, your questions for the Q&A session at any time throughout the webinar. So whether it's the beginning or at the very end, submit them all throughout. And unfortunately, with this large amount of pre-registrants, we cannot open up the phone lines for questions. All questions need to be submitted through the Q&A chat toolbox. And if we do not get a chance to respond to your question, or if you would like to discuss a topic in more detail with the presenters, feel free to contact them directly. Second, for those of you who just joined, please make sure that you are on mute. Both your computer and phone microphone should be on mute. If you would like to see the phone and audio broadcast connection instructions again, please refer to the confirmation email I sent to you today, or if you go to the top left-hand side of your WebEx screen, you'll see a tab labeled Meeting Info or Event Info, and some of those connection instructions are included there as well. But like I said, please remain on mute. Okay, I think that takes care of all of our housekeeping matters. Let's get started. I'd like for our presenters to go ahead and introduce themselves, and I'll jump it off to Nick.
Thanks, Michaela. Can you hear me okay?
Yes, I can. Thank you.
All right, fantastic. Nick Sands here. Currently working with DuPont. I've been working with DuPont for 24 years or so, and had a good run so far. I'm a certified automation professional and ISA fellow. Get to work on control system projects here. There's some very large projects, $500 million, and some small projects, $5,000. So, and also have been a supervisor for a group of control engineers that worked on a wide range of projects as well. So I've gotten to see some of the good and the bad and the ugly of projects for all the way around. So. And I'll pass it over to Matt.
Yeah, this is Matt Sigman. Good morning, good afternoon. With Maverick Technologies, been with Maverick for about 16 years, and about 20 years experience in the industry. Started out in DCS and have done a lot of that over the years, but also other control system work. Actually began doing control system work as a co-op in a paper mill doing Honeywell PDC 3000 in the early 90s. And so got a lot of experience in chemical, pulp and paper, pharmaceutical. Currently I'm the director of DCS Next at Maverick Technologies.
Hello, my name is Charlie Skeen. I have been with Maverick actually a relatively short time, only about 9 months now, but I do have 23 years of experience in the process and automation engineering space, chemicals manufacturing, batch processing, project management. I'm currently a program manager for chemicals at Maverick Technologies.
Nick, I think you were going to just briefly go through the agenda and then kick off the first part of our presentation.
Yep. So we're going to start talking about some of the challenges, some of the dilemmas we might face around projects and front-end loading, then cover some of the mistakes that might lead to and the consequences of those mistakes within your project. So then going into an overview of the front-end loading process, what some of the good processes might be, the goals and the benefits of doing that, and then the project value itself, some new opportunities or methods, and then we'll go into the Q&A session. So we'll start off, and I get to go first here. The classic project, so hopefully many of you have been involved in capital projects, and you know the old joke about capital projects is you can get any 2 out of 3. You can have it fast, good, or cheap. And by that we mean the fast projects will stick to their schedule or have a short schedule. The good projects will get you the functionality that you need, and the cheap projects will keep it on budget or less. The thing with that joke is you're not guaranteed to get 2 out of 3, right? You can get 0 out of 3. You can get something that doesn't meet the schedule, blows the budget, and still doesn't work when you're done. So 2 out of 3 is just what you might expect if the project's done pretty well. If it's not done well, then you can really lose all of that. And so the front-end loading is kind of the key to being able to understand, are you going to get the functionality you want? What resources go into that? So how do you budget for it? And then how do you put all that together with manpower to get it on a certain schedule? If you don't do that, you'll end up losing money for your business. It's delayed startup, not having the sales available to your customers. You could lose customers as a result of that. Cost overruns, which, and certainly in the company I work for, you can get in quite a lot of trouble if you've gone far over your budget. And one of the worst things is if you stick to the budget and the schedule, but it doesn't work the way you need it to, and you don't get that performance out of that control system. And that's bad because it really reflects on the control engineer. So that's the one that I guess hurts most deeply in my heart, is if we get a project done and it doesn't do what it needed to do. Sometimes we'll run into these situations where the business need is identified and there's a short time frame for them to hit some target opportunity. And so they decide to fast-track the project. And unfortunately, for business managers I've worked with, the fast track means, we get to skip some of the work, like front-end loading, like functional descriptions and those kind of things. That's not what fast track's supposed to be. Fast track, still, you're doing all those necessary steps for the project, but now you're going to do a couple of the steps simultaneously. And that's always a little bit risky. The one that I always dread is for the types of processes I've worked with, they're higher hazard processes, and we're doing a process hazards review or a process hazards analysis, a PHA, and that PHA will get put to be done in parallel with the design. And so they're modifying the design as we're doing the PHA with the design information to try to identify, do we have adequate protection from our hazards? And that always ends up to be a challenge to try to get the right information at the right time of the project. The thing about that front-end loading and having the information at the right time is if you can do your design, your front-end loading design, that early phase of design, so that you understand those full requirements, it's kind of built in. You've got it estimated. It's on the schedule, those kind of things. And rather than identify the need to make a change in the project as you go further down the line. And the curves here kind of show the cost of the changes go up dramatically on essentially an exponential curve the later in the project that you have to do things. And if you've ever had to redo something like graphics or configuration after the construction is mostly complete, and now it's just the control system, the checkout and commissioning is your major task, and you have to start modifying the configuration at that point. I've seen multi-million-dollar, hundreds of million-dollar plants delayed in startup for months for control systems work. So that really reflects poorly on the control engineer. So we've got to make sure that those things are identified as early in the project as possible and can minimize the cost, the impact to the schedule and to the budget if we do that work up front. So if we don't, what are some of the common mistakes? The things I've seen, and granted, there's a lot of people on the line today. You've probably seen a wide range of things, but some of the top things that I've seen. I do a lot of work with safety instrumented systems, and when we miss the need for a safety instrumented function, a safety interlock, and we have to go back and add that, those systems are so much more expensive than the basic process control systems. So the safety systems really have a lot more cost. And when we go back and have to move a lot of things or add a lot of things in order to provide additional safety interlocks, that gets really expensive really quick. And the whole life cycle process of doing that work as well, you're going through your safety requirements spec, and you're going to have to do the validation and the planning and the test procedures. So it adds a lot of cost if we miss that. The worst case I think I would recall is where we had an analyzer that we had to add as part of a safety system. And then when you're dealing with analyzer systems and safety systems, it gets really outrageous, long delivery, those kind of things. Probably the next one is batch work. Well, we've got a batch unit, and we're going to try to do the sequential control. Michaela, can you still hear me?
Yes, I can hear you just fine.
Okay. So in a situation like that, if you do the project estimate and you build your schedule based off just a direct I/O count, just like it's the same as a continuous control process, you have the basic process control layer, and then you'll add your automation, your batch automation layer on top of that. And that takes dramatically more work, more time and planning to work through, because really you have to go through all the abnormal conditions and make sure that your handlers are set up for those kind of things. So the estimate, if you just come in and estimate a project off of I/O and how many resources you'll need off of I/O, rather than what kind of work will it take to do the sequential control correctly, the batch control, and if you have to put a recipe system in and then testing all of that. So that's a big place where we make mistakes. A common mistake we had all the time was we'd have a place and we're adding another unit, or we've had one unit on a control system and we're doing a migration for a second unit, and it's been a few years, and someone says, "Oh, I want you to do unit 2 just like number 1." But then these things are going to be different, and we almost have to reverse engineer what is the functionality in unit 1 to make sure we understand what that is. Well, what will it take for us to put that in for unit 2, and where do those differences impact it? But people would always want to skip any estimation step. I want you to do it just like unit 1, so just give me an estimate for that. And then if you don't have that functionality documented, you really can't develop a reliable estimate for that. The other place that I see more is around historian information and reporting and passing information up to manufacturing execution system. And that can be some specialized work, and if people don't understand the skills that go into that, and they won't do a good job of estimating that work, and again, you'll end up with not having that functionality or not having the functionality ready on time for your project. Those are kind of the classic things I've seen for many years. Lately, what I see is a different set of requirements that we've raised our expectations in some specific areas of control system projects. And one of the big ones is around cybersecurity requirements, the ISA 99 standards, and really making sure that we've designed the network for security and subnets and putting in the firewalls and understanding the protocols and how we're going to manage the accounts and then how are you going to make sure you can do patching and antivirus upgrades. So those things really are causing us to have spend a lot more time on the network design. Of course, as we've gone to Ethernet and the commercial off-the-shelf equipment, the cybersecurity requirements have become challenging for us in just the last few years. Around getting the performance that we want, there's been a lot of work done around high-performance graphics and high-performance human-machine interface design, and really thinking about the person, changing some of our classic Christmas tree displays where, in the early days of DCS, we could have 16 colors, and we made sure we used them all on every display. And now the graphics, I was just building some graphics last night, and those displays they're all grayscale with color highlighting functionalities and kind of built with some layers of functionality with some scripting that allow really to highlight things of importance to the operator. So really focusing on what does the operator need and how do we get their attention when we need their attention rather than just using different fields and doing some task analysis. We're going through and making sure the displays match the procedures and things like that. So that's different. And then the one area I spend a lot of time personally on also is alarm management and making sure that we have our alarms rationalized prior to startup. So that extra work, making sure we only have the right alarms built into the control system and we have the right information to train the operators prior to startup. And as we do migrations, we can change a significantly number of the alarms. It used to be a migration we might actually give the control engineer a form or the process engineer a form and say, tell us, give us a high, a low, and a low alarm for every point. So we were using all those valuable alarm settings. And now we want to make sure it's just the alarms that the operator needs to respond to and take action for that come in. That alarm rationalization work on a migration, making sure you've got the right things prior to startup, can really take some time and some effort. And it's unanticipated in a lot of people's project schedules. So, and finally, are you doing some simulation for training, for testing of control strategies and batch control and those kind of things? So that expectation may have been there for a while, but I see it more and more on projects I work with. We're going to work on those kind of things. So I think that's teeing up some of the challenges, and I'm going to turn it over to Matt to see how you might meet some of those.
Thanks, Nick. Charlie and I are going to kind of tag team the rest of the presentation, talk about some of the other agenda items Nick went over earlier. I'm going to let Charlie kind of lead off here with some consequences of those mistakes, and then we'll go a little bit further into what is FEL and goals and values and things like that. So, Charlie?
Thanks, Matt. As Nick said, there are mistakes that can be made. There are significant elements of scope that can be underestimated or just not included at all. And so let's talk a little bit about some of the consequences of those mistakes. The first is the project cost can absolutely escalate very quickly to where the project that was previously justified and competitive moves immediately to being uncompetitive with your industry peers. The types of costs that we're talking about can quickly be, plus 20% versus your peers. Schedule would also be impacted either because of rework or additional work that has to be done late. That can also be another plus 20% on the schedule. And then, another consequential impact of that is that other projects that were also planned can't be staffed properly because you're spending your time recovering on the projects where the mistakes were made. what we'll transition to quickly is that there are proven FEL approaches that can and do reduce these impacts if you invest the time and energy in doing best-in-class FEL. Projects often get staffed late when you realize late that you have other work to do, and it could be a combination of you just don't have the right people on the bench available with the skills to do this additional work, or you can't afford the resources to do the work because it wasn't in the original authorized budget. And as Nick alluded to earlier in the presentation, many times folks will say, well, let's just go ahead anyway. Let's just get on with it. This is a fast-track project. We really have to get done on time. And one thing's certain, going ahead anyway almost always takes longer and costs more. Matt?
Yeah, so just kind of want to rewind, and many of you may be pretty familiar with the FEL process terminology, kind of the overall purposes of it, but we thought it would be good just to take a few minutes here and just kind of review the basics of FEL from kind of a 30,000-foot view. Kind of before I begin with that, just a couple of notes. A lot of the terminology we'll use today is consistent with kind of industry standard for FEL. You can find a lot of that with the IPA organization. You go to ipaglobal.com and do a little research if you're not that familiar with FEL processes and terminology. Again, I'm just going to hit kind of a high level. Also, I think as Charlie and I kind of move forward and talk about some of this, you'll probably hear pretty often us talk about FEL as it relates to DCS migration. That's just one, just to kind of help provide some meat to the bones in terms of the application of FEL. But also that's a lot of what the needs are in our industry right now. That's not to say a lot of what we're going to talk about in terms of the value and benefits of FEL wouldn't apply to other control system projects. It definitely would, whether it's a greenfield plant, it's a large PLC migration, or maybe it's a migration of manual control, single-loop controllers into a modern control system. In any of those kind of large-scale control projects, the FEL process would bring tremendous value and benefit, and then help avoid some of the risk and issues. So just again, I want to take a few minutes to talk a little bit about what is FEL. If you're not familiar, it stands for front-end loading. Some folks use the terminology front-end engineering and design, or FEED. Those are related, not one and the same, but fairly related. FEL is a process for providing engineering evaluation and assessment prior to actually beginning the project and execution of the project. So it's doing the requisite beneficial upfront engineering work, but also project planning, so scheduling, estimating, resource planning, risk assessments, things like that will be required in order to execute an effective project. Typically, the FEL is broken down into 3 steps. I'll show these in a little bit more detail on the next slide, FEL 1, 2, and 3. Some end users that we work with have kind of their own alternate terminology, but when you boil it down, you're talking about the same overall stages. Occasionally, you'll see FEL 0 mentioned, but generally speaking, it's 1 through 3 that are most common. Each step has a different technical focus, and each step generally includes the estimation of a capital budget and a preliminary schedule for the implementation. And as you might expect, as you move forward from 1 to 2 to 3, the accuracy of that budget and all the other deliverables and tasks increases. So let me kind of, with that said, let's get to the next slide. So graphically, this is how it would typically look. And again, kind of this is a high-level view of it. There's a lot more detail that goes into each of these stages. FEL 1 is typically plus or minus 50% from an estimating standpoint for, again, the project budget. It's, often we call kind of a back-of-the-napkin high-level estimate. Not a lot of effort and time is put into doing that, again, to get to that level of accuracy. The purpose is kind of recognition of need. What project do we need to do? What's the overall structure and scope of that? And is it justified to move further down this process and begin to do more effort and spend more time and perhaps funds on doing some of this upfront engineering? So that FEL 1 is typically that initial toll gate to then move further in the process. Many projects may not make it past FEL 1. most DCS migrations, for instance, do because of the obsolescence of the existing DCS. So it's usually passes that first toll gate. FEL2 can be a fairly extensive effort. Generally, the purpose is to get to plus or minus 25 to 30% on the capital estimate. We also recommend that at the FEL2 stage you do both TIC, or total install cost, as well as total cost of ownership, or your long-term cost estimate. And the benefits are to help you do a more thorough comparison of options. And that kind of speaks to one of the other main purposes of FEL2 is to compare options and to do the requisite upfront engineering and analysis to select between options. Those could be platforms and technical solutions. It could even be the way the project is executed. Should it be done as a single project, one shutdown, or should it be split up into 4 or 5 over a few years and multiple shutdowns? Things like that need to be analyzed and fleshed out at the FEL2 stage to determine those preferred options and to refine the plan for the project. And then you go to FEL3, which is the final part of front-end loading, or often front-end engineering. At that point, you want to be at plus or minus 10%, sometimes more accurate if the variables allow to be even closer, but generally speaking, plus or minus 10%. At this stage, you want to complete front-end engineering and design, finalize your execution plan, which would include, but it's not only this, your scope, of what services and what tasks and what deliverables will be performed and completed, your cost estimates, schedule, and also, secure final capital funding approval. It's important to note here on the front-end engineering design that one of the key principles is to do a sufficient amount of front-end engineering to produce the estimate, at plus or minus 10%, and also to have a good preliminary design to move forward with the project. It isn't necessarily to complete all the design work. There could be detailed design work like control panel design, construction packages, things like that would be part of the project. But it's to complete enough, but not too much of the front-end engineering design to then move forward and to be able to put a good plan together. And then finally, the actual project. So that's what we're all pretty familiar with. So the detailed design, the development, and by development, I mean all the programming of graphics, configuration, custom programming, interface programming, all those kind of core things we often think about when we think about doing a control system project. And then testing, internal to the factory, and then on-site, and then installation and commissioning. So that's kind of a high-level view of what goes on with FEL. Again, there's a lot more detail and things behind this, but just kind of wanted to give everybody at least a preliminary view on it if you weren't that familiar with FEL. Just some goals, and I've probably touched on this a little bit as I've gone along. Overall goals of the FEL process, again, is to use it for a framework. And I mentioned here DCS migration. Again, it could be used for a number of other types of control system projects, but it should be used as the framework, the process for doing that initial investigation, getting your arms around what you have and what needs to be in the boundaries of the project to do that scope boundary definition, do the upfront conceptual planning, feasibility analysis of different options, and then finally to put the requisite justification together for getting the project approved. Historically, traditionally, the FEL process has 3 goals, and one is, kind of seems obvious, but should be stated, is to provide the justification and help successfully navigate the corporate CapEx, capital funding approvals. Oftentimes, and this happens fairly often in just our experience, this is where a lot of projects fail, or at least they get delayed year after year, is there's not sufficient justification for the project. And oftentimes that can be because the front-end loading is not performed to an adequate level, and the backup material, if you will, is not there. It's often not enough to merely say the existing DCS is obsolete according to the OEM. There needs to be a lot more estimation and planning and analysis of options and that kind of thing put together in order to justify a project, including what we've seen oftentimes is looking at that total cost of ownership over 10 to 15 years can help justify projects. So, again, that one's pretty obvious, but well stated. Number 2, to provide reliable preliminary engineering and project execution planning, scope, schedule, budget, but also the how to do preliminary project plans that will explain how we're actually going to do the cutover, what systems will be hot cutover, what systems and I/O will need shutdowns for, how will we accomplish this in 5 days, what happens first, what happens next, how will commissioning and checkout occur, things like that that really have to be thought out. Often we recognize as control engineers we need a good kind of scope of work, we need a schedule, we need a budget, but we also need kind of a guidebook for how we're going to accomplish this. Again, as I think Nick talked about earlier, to make sure we minimize production downtime, and worst case scenario, our best case scenario, we avoid any unplanned process shutdowns. And then finally, number 3, I kind of mentioned this in my last point, is reduce the implementation risk for cost, schedule, and system performance. Again, we want to, if we do FEL well and we do it optimized, best in class, we should minimize our cost. We should have a very efficient, well thought out schedule that is accomplishable. And then finally, the system and the process should operate as designed. And if we do FEL well, all of those should be accomplished. So with that said, I'll turn it back over to Charlie.
Thanks, Matt. So one of the things that we hear a lot from clients are things like, we only want to do enough work to get a number, or we really just need to know about how long it will take. And I think when you look at the, some of the things that have been presented so far, some of the issues all the way through, some of the detailed steps in the process, a structured FEL process, doing it in an effective way and comprehensively is absolutely critical to project success, and in as much as it's going to reduce your risk and guarantee the delivery of the results. And so there's data available to look at that. And these two graphs you see side by side are a little bit complex, and let's just talk through them. If we start with the graph on the right, if we look at the performance, the measured performance of the FEL, so this is a detailed look at the actual quality of what's done, and you can see between just 2 regions over about a 12-year period, there's some markets kind of stayed steady and did what was measured as fair FEL. Other markets focused on doing effective front-end engineering and are starting to get between good and best performance. And then if you look at the graph on the left, it'll show you what the cost index, so this is a comparative cost index for a similar class of plant. As you can see, the folks who really didn't improve FEL kind of stayed normalized with their peers. Those that invested properly in time and effort to do FEL saw a favorable cost index, and this one about a 7% benefit for the installed cost of the plant. So it can help your business be more competitive. And again, what we've found in our experience, FEL done well, it almost always pays for itself in terms of the schedule benefit you get. And financially, it almost always pays for itself in terms of avoiding late changes, avoiding rework and recycle, and it actually helps you effectively manage the cost of the system. And there's much more data available through, as Matt gave the IPA reference. There's data like this out there, and it has been studied for literally decades. Okay, Matt?
Yeah, just to kind of talk a little bit more about some of these benefits of good FEL. One kind of caveat I would add to this, what I'll talk about here, is to not do FEL well, kind of the inverse is true, means that you potentially or likely will miss out on some of the benefits and, or even worse, cost yourself a lot of time and money. So just kind of pointing that out. So kind of a couple of points here. FEL performance, so how thorough, how well, how complete you do front-end loading is a leading and highly accurate indicator. Charlie talked a little bit about that, and Will again. It's a leading and highly accurate indicator of project performance. I would actually stipulate that it's the main indicator of project performance, even more important than certain, whether certain individuals are on the team or not. And so just kind of keep that in mind. But specifically, capital cost performance and return on investment. Is the company going to get what it paid for? How well FEL is performed will be a huge, if not the primary indicator of that capital cost performance. But historically, most FEL deliverables and processes focus on kind of doing the minimum. That's often what we hear is what's the minimum we need to do in front-end loading in order to get this project approved and keep it moving forward. And there's some value to kind of thinking about that, and certainly we wouldn't promote spending more money than is necessary or time. But often, historically, FEL deliverables and processes were focused on minimizing risk, production downtime, doing project planning, estimating, selection of technical solutions, and all those are very important and certainly are part of front-end engineering or front-end loading. But front-end loading should do more than that. It shouldn't just focus on minimizing CapEx spend, but it should focus as well on long-term operating expense spend, as well as potential improvements in the way the process is controlled and utilizing newer technology and capabilities of newer systems, interoperability, connectivity, access to data at the enterprise level, and just base features of newer DCSs and other control systems that did not exist 20 to 30 years ago in the first and second generation control systems that now are built in. And so if when you do front-end loading, you don't look at potential improvement and doing things better and utilizing those tools, then you're missing an opportunity. And so kind of the final point there is a truly comprehensive process. FEL process will focus more than just technology selection, more than just the requisite project planning and budgeting, and more than just CapEx. It'll focus on OpEx and long-term value and actually improving the way the system is controlled, the process is controlled. And so, often we tell folks doing a big DCS migration or any other control system project is an opportunity to improve the way the plant is operated, improve profit, improve yield and safety and uptime. And so leverage the capabilities in the new system and the engineering process and the front-end loading process to deliver those values. So then that kind of speaks to what I wanted to talk about next is, so how can the FEL process create value? Just got a few examples here on the next couple of slides. This is not comprehensive, but common things, as Nick talked about earlier, just common things I think we've seen over the last several years as we've been doing a lot of this kind of work. The first is, and I think I've seen some questions come in on this one, is price and support contract leverage with OEMs. You particularly see this in the FEL2 stage, but certainly can be present throughout. So as you're doing FEL work and perhaps in the FEL2 stage comparing platforms or comparing solutions, you often and we often are getting competitive price proposals from more than one vendor and helping clients sort through that. So that what should that pricing, what should that comparison look like? Well, first of all, it should be comprehensive. It should include both upfront software and hardware costs, but also long-term maintenance costs, hardware, software, services. So it should be comprehensive. It should include technical comparisons in addition to cost. Both are important. And then complete cost estimates by the platform and the solution options and any other options or variations. You don't want to overcomplicate things at the FEL2 stage. Typically you want to look at between 2 and 4 options. Any more than that, you begin to have diminished returns. So oftentimes between FEL1 and FEL2, we recommend that the options be narrowed to the most viable and preferred. The other thing is, I think I touched on this earlier, total installed cost, so that upfront cost should be estimated as well as total cost of ownership. So as you look at different options and different solutions, you should look at, what's it going to cost me to buy the car, and then what's it going to cost me to operate and own the car for 10 years. That's my analogy, and both are important. And it's interesting to look at that across different solutions, different platforms, and then compare those. And having all that data then helps you as an end user negotiate and come to a good, fair agreement with your suppliers. And so, again, kind of the last point, it provides critical information and leverage, fair leverage, to be used to reduce both CapEx and OpEx spend. So that's one key thing that we often see in the FEL process that helps deliver value, and from a dollars and cents standpoint. Also, and I touched on this earlier, this is one example, is improvement of historian functionality and enterprise layer integration. Again, a lot of the newer systems have a lot of built-in functionality that wasn't there 20, 30 years ago, and honestly necessitated the use of a lot of different third-party systems and platforms to historize data and provide that data upstream to the enterprise layer. A lot of newer systems have basic functionality, very good basic functionality built in. Doesn't mean you need to scrap your third-party system, but it is something you would want to look at and figure out how to leverage, and to what degree you would leverage. They also provide a lot better interconnectivity to enterprise layer systems. So how will that be leveraged? Again, to uncomplicate what is maybe the existing installation. So that's a couple. A couple more is, and I've touched on a lot of this already, is what I would call comprehensive project execution planning. Oftentimes we've seen project plans and estimates put together that are they're helpful, but they're not complete. Estimates that include engineering and hardware and software, but don't include installation or don't include maintenance costs. And so again, it's very important as you put estimates and schedules together that they're comprehensive. That when we say it's a total cost, it's a total cost. It includes everything. That when we put schedules together, it's detailed enough, and that the project can be executed based on that. And when we think about who's going to do what, who's going to do the graphics, who's going to do the installation, who's going to supervise the commissioning, those kinds of things have been thought out in advance, so that you're not figuring that out halfway through the project, which, as Nick talked about, will likely cost you more to figure it out later. And so main point there is in FEL 2 and 3, comprehensive plans should be put together that will save money in the long run. Might require you to spend a little bit more time and money up front, but it will more than pay for itself in the long run. And then finally, and Charlie's going to touch on these a little bit more in a minute, so I won't go into any detail, but kind of some of the same things Nick talked about. S88 batch optimization. There's a lot of batch systems out there running on older DCSs and PLC platforms that were not implemented using S88. They're perhaps 30 years old. There's an opportunity to bring those processes up to modern standards and thereby increase efficiency, interoperability, safety, all those kinds of things by using those modern standards. Alarm rationalization, high performance graphics, using ASM standards, cybersecurity. So use the FEL process to look at those kind of opportunities and see to what degree they can be implemented and then benefit you in the long term. So that's kind of the end of that. Some of the ideas about creating value. I want to turn it back over to Charlie for some kind of final comments on some of these things.
Thanks, Matt. So again, to review really the value statement around good FEL and feed practices, the proven approaches can and should reduce the impact of the mistakes, especially cost, schedule, and operability at the end of the day. It will drive reductions in the total install cost and the total cost of ownership. It'll help you maximize the return on investment for a given project and really minimize the total CapEx spend required. A small investment now will save a lot of money later. It does require a combination of, quote-unquote, best practical FEL deliverables and the use of value-improving practices throughout the project, and we'll see some examples of that in a minute and talk about what some of those practices have been in our experience. And optimized front-end loading for a DCS migration should be between 6 to 10% of the total project install cost to achieve best practical FEL. And it's a pretty broad range. The one thing that's a little bit unique about migration projects that's different than a greenfield project is, of course, you have the reverse engineering part that has to be done. And depending on the complexity or relative incompatibility of the original and target platform, that will be more or less work. But again, nominally for planning purposes, that 6 to 10%, if you invest that in FEL, you will get the benefits that we'll see here in the coming slides. So this slide is a summary, again, building on some of the available industry data. If we look at the left-hand side is relative capital cost. So again, for a similar set of projects, similar scope, similar complexity. And then the x-axis is best practical all the way to basically essentially no FEL. And by these definitions, I would say you could typically benchmark the I just need a cost to get the money kind of view is going to be absolutely between poor and screening. And if you do these things well and include value improving practices, and we've talked about some of those already, right? There are very specific practices for a whole plant, but some of the things like S88 optimization, graphics optimization, high performance graphics, alarm rationalization, overall simplification of the third-party interfaces required, those are specific value-improving practices that you can do for a migration project or a DCS-specific project. And you should see costs that are 0.83, 0.85 the norm if those are combined. If you just did good FEL and didn't necessarily pursue those things, you'd see about a 5% advantage in price. Okay, the next one. The other side of this coin is the schedule. And again, these things all done well ensure that the quality's done well. But there is a perception that the time to do FEL means that the schedule tends to be extended. And that's simply not true. If you look at, again, the cycle time, the total cycle time for the project, so that's from initiation through startup of the facility, you'll see about a 5% advantage. If you look at the construction envelope in particular, because you would have done things like good constructability reviews, good planning for the execution phase, you'll actually see up to about a 10% advantage in that actual construction schedule. And if we focus again on the migration space, remember the red line or the construction schedule is the period of time your plant is unavailable. So a 10% advantage there actually helps you get back up and make money much faster. And really to highlight some of the innovation opportunities that we've found, cybersecurity improvement is absolutely a space where you can, reduce the risk of operating the system long term and some potential interruptions and upsets later that can be very costly. Already mentioned S88, alarm rationalization, and high performance graphics also are opportunities to not only provide a better interface and a more operable interface. What we found is these things implemented actually save you money. And a good example of that is the space of high-performance graphics. A lot of folks have historically said, I just want to move my graphics over and I'll optimize them later. What we found is through an effective facilitation process and implementation process for high-performance graphics, you can see the total number of graphics can actually be substantially reduced by as far as a factor of 2 in the most extreme cases. So if you do the upfront work well, you'll actually have less work to do in the detailed design and engineering and implementation phase. And that's a part that might be a little counterintuitive. But again, we've worked through several of these and have seen those sorts of benefits. With that, I think we're ready to go to the Q&A session. I know I did see a lot of questions come across, and I think we've tried to provide answers to some of them as we go, but we can still run through them, Michaela, and then if it was answered in a subsequent slide, we'll address it that way.
Okay, great. Yeah, I'll read out the question, and if you've already answered it, then we can just skip along to the next one. But thank you all. That was fantastic. And we're going to go ahead and move into our Q&A session, and we've already received quite a number of questions. But continue to send in your questions through the Q&A chat box there on the right hand side of your screen. It's not the chat toolbox, it's the Q&A box. It's got the little question mark next to it. But continue to submit your questions at any time. And if we run out of time and we're unable to get to your question, then feel free to contact the presenters directly. Okay, our first question asks from Randy, should each FEL phase also include an update/summary of the impact on scope, in addition to schedule and budget?
Yeah, I can start. This is Matt. I'll answer that one, and Charlie and Nick, feel free to chime in. The simple answer is yes. As you move forward through the FEL stages, the scope of the project should be refined, and there may be cases where a couple of examples, as you kind of define the boundaries of what's in, what's out, those may expand or they may contract, and or they may be split up. As you begin say a large DCS project, you may be looking at a whole plant, 20,000 IO for a large chemical plant maybe. And as you move forward through the FEL process, you're going to determine how to split that up by process area, system, controller, and that the scope is going to become more detailed as you move along. And again, kind of consistent with the level of estimate. So the level of scope that you need for a plus or minus 50% estimate, and then a plus or minus 30% estimate, and then a plus or minus 10% estimate, right, you would expect that to get much more refined, so that by the end of, again, FEL3, you've got a fairly detailed scope together for both engineering as well as any field services or construction pieces of it. And including, and what I didn't mention this earlier, but what's typical in the FEL3 stage is an RFP and preliminary design and scope of work for any construction services that might be performed by a subcontractor. So, yeah, I would expect that. You would normally expect that scope to get refined and changed over each stage.
Right. Thank you. Next question comes from Greg. He asks, what is typical cost of FEL2 as percent of TIC, and what is the typical cost of FEL3?
Good question. I'll kind of give some high-level principles, kind of touching on, I think this question may have come in before Charlie mentioned the 6 to 10%, so I kind of draw attention back to that. And again, that's kind of optimized FEL. Certainly, you could have some FEL efforts that would be outside of that. I think more on the high side, if you were in a greenfield situation or a large complex migration from manual controls to a DCS where there isn't an existing DCS, you could see front-end loading be, plus 10% because there is no system there existing, and the front-end design can be pretty extensive. So again, I would kind of hold up to 6 to 10% of total TIC for front-end loading. So if, for instance, we're thinking about a project where the total value is $5 million, you would expect the FEL to be, at least $300,000 to potentially $500,000 or more. And how it splits up between FEL2 and 3, there's some variables in that. Kind of what do you do in FEL2? What do you do in FEL3? How many? If you're looking at different platforms in the FEL2 stage, how many? So, but you could typically see FEL2 being at least half of that. So if we're talking 500,000 of FEL activity, I would typically expect the FEL2 to be at least half. But again, there can be some variation of that. Charlie, any comments on that?
No, I would agree. I think we see FEL2 being, say, 50% to 70% of the total FEL budget. And as you pointed out, it depends on the number of platforms being evaluated. But FEL2 is a pretty heavy engagement period, right, between platform and technology selection. This is where you really make the first pass at a really detailed TIC and TCO estimate. And it's really where you absolutely fully quantify and capture the technical requirements for the given project and then evaluate each of the platforms against it. So it's a big chunk of work, and on that kind of, I would say multi-platform consideration is going to push you closer to that 70%. And then, but if it's light, it could be, split evenly.
Yeah, I agree.
Okay. Next question comes from Cheryl. She asks, we have acquired a plant that uses brand X, DCS, and SIS or SIS. Our company has a service agreement with brand Y, DCS, and SIS. We are being pressured to rip out brand X and replace with brand Y by operations due to their comfort with brand Y. What analysis should I perform to ensure that we are making the right decision from a total cost of ownership point of view?
Well, and I certainly don't mean to be facetious with my answer, but my short answer is this is exactly why you do an FEL2. And so what I would generally recommend, that's not an uncommon, with the acquisitions that happen in the process industries all the time, this is a fairly common thing we run up against, where you have different plants that have been acquired over the last 10 to 20 years that have different DCSs, and then there's a corporate standard and those kind of variables at play. Again, my short answer would be I would recommend doing an FEL2 and comparing brand X and Y from both what would the cost be to rip out brand X and put in brand Y, and look at the long-term benefits and cost to that, and weigh those out from a return on investment standpoint. It may be that it's if brand X is a 20-year-old DCS and it's nearing obsolescence anyway, then that's one scenario. If brand X is a fairly new DCS that was put in 5 years ago, that's going to be a lot harder, hill to climb from a justification standpoint. That being said, we have seen some cases where, decisions are made at a corporate level to standardize, and that's what's going to happen. So those would be some of the variables. And I think Cheryl, you had a second question that was kind of related to total cost of ownership. So I'll just kind of hit that one as well as I talk about this. And again, generally in the FEL2 stage, we would recommend doing both the TIC and TCO. And so if you were comparing brand X and Y, you would do an estimate for the upfront cost, of the new system, or, say comparing two new systems. But you would also look at the TCO. And what typically is included in TCO in our involvement is the cost of the software licensing over, say, 10 years for that system, the cost of hardware maintenance, so spare parts, and having a spare parts agreement. And so there's a cost of that. There's a cost of just services to maintain that DCS, and those would be all costs that would be kind of outside of your company. They're going to be purchase orders. The second big category in TCO would be your internal cost to maintain those systems. So maintenance technicians, engineers, and others to make sure those systems are maintained, and your own spare parts inventory. And then the third category would be the cost of any other, say, outside engineering firms, system integrators that might help you. We're not talking about major projects, but to maintain those systems over, say, 10 years. And so in the FEL2 stage, you don't want to just, look at your crystal ball and guess at those numbers. You want to actually go through a fairly robust process to estimate that. And you begin to lose accuracy 10 years out, but you can do a fairly good relative comparison of options to do that. And so I think if you were looking at brand X and brand Y, again, that's what I would recommend, is looking at it from both a TIC and TCO standpoint, and with an eye on justification. But again, I say all that knowing there's always this caveat that if a corporate standard is X, that's what it's going to be. Then it becomes a question of how and when do you do it most effectively. Charlie and Nick, feel free to chime in on that one. That was my thoughts.
No, I think that's spot
on. Matt, it's Nick. I'll just add one more thought there. My company also used to have some guideline systems that we would use, and our whole framework of acquisition and divestiture has changed over the past few years, and we would no longer spend our capital replacing systems that weren't obsolete, like you were saying. So now it's a matter of making sure that our our workforce can, at different sites, or our leverage resources can support multiple different systems, because the reality is, as we're acquiring plants with new systems, we're not going to spend the money to replace them.
Right.
All right. Thank you. Our next question comes from Alexandre, and he says, in the company I work, we usually associate FEL phases with feasibility study, FEL 1, conceptual design, FEL 2, and basic design, FEL 3. After that, detailed design, implementation, and commissioning is altogether named implementation phase. Is that correct? And then he notes, I'm talking about how our greenfields projects are broken down.
This is
I
Charlie.
can answer that one. Go ahead, Charlie.
I was going to say, I mean, without knowing the details of the referenced work process in terms of what exactly is included in feasibility study, conceptual design, and basic design, the words are very much consistent with, as indicated, where FEL 1, 2, and 3 would be. So I would expect that they're very similar definitions.
Yeah, I would add, it sounds very similar in terms of kind of the categories. My only caveat, just reading those descriptions, it sounds like they're very focused on the design engineering aspect of the process, and I would just kind of commend that that's a big part of it, but there's more to FEL than the kind of requisite engineering part. There's the project planning, estimating, and all the rest of it. So, but generally, those categories are accurate, and it's kind of like I said earlier. I think at the beginning of the call, different companies have different terminology of what they call this, but a lot of large users do have some semblance of an FEL process, even if their terminology is a little different.
All right. Okay, our next question comes from Larry. He says, what do you feel are adequate capabilities out of the box to integrate third-party applications with the DCS?
Charlie, you want to, maybe Charlie and Nick?
Yeah, that one's a little, I'll start, and Nick, you can jump in. But, I mean, I would say the observation that I've made is that all of the modern generation DCS platforms, their ability out of the box to interconnect both from hardware and software standpoint is substantially greater than what you would have been able to buy 10 years ago. So, I mean, I think if you, and again, without naming names, I think if you look at the modern significant players in this space, all of them have what I would call adequate capability. Each of them also have very specialized capabilities, and so it kind of depends on what you're trying to integrate it with. I don't know, Nick, do you want to add more?
Yeah, I would agree with you, Charlie. It depends on a lot of recent projects, and I know Larry works a lot with, or has a lot of knowledge around field bus and those kind of systems. And a lot of our projects today, we'd have a whole bunch of different packages that would have different communication technologies, Profibus or field bus or OSSIBus, that we would have to be able to integrate and to work with. And so I think understanding what the requirements of your system are is more important than just, what are the out-of-the-box capabilities of a general system. If it's got a lot of out-of-the-box capabilities and it doesn't match any of the things that you need, then it doesn't really help you that much. So I think it's pretty common for us now to have multiple different types of interfacing required on our projects.
And I would add, whether it's in FEL2 or whenever, if you're doing a technical comparison of different solutions or platforms or technologies, it's important to capture what those requirements are going to be up front before you even begin to compare. So what communication protocols, what kind of processor speed, what kind of I/O capabilities, what kind of I/O technologies in terms of things like field bus or wireless or whatever. So what are and that can be a fairly long list of technical requirements. And so you would want to put those CTQs together, and then as you begin to compare the platforms, capture that data for each of the platforms, each of the solutions, and then you can do a good comparison and make sure you don't miss anything. Again, part of the FEL process is making sure you don't miss a critical technical requirement that crops up later and costs you a lot of money.
Right. Larry asked another question. He said, overall, how much money do you expect to save by taking a more proactive FEL approach versus not having one? 10%, 20%?
That's a great question, and I'll refer back to the couple of slides we looked at. I think straight up off the capital cost, I mean, you should see 15-20% advantage versus your peers or past practice, depending on where on the curve you are. Probably the more significant benefit, however, is especially in the space of migration, is going to be in that construction window optimization of 10%. And if you can shorten that cycle by 10% and get that many more production days, I mean, a lot of companies are pretty much sold out right now, and that benefit could be drastically more than the capital cost savings, just depending on the profitability of your business.
I would also add, kind of as we talked earlier about the benefits of good FEL. I think part of your question, Larry, was, versus not having one, and so the potential risk of not doing FEL can be much more than 20% of total project cost. You could pay significantly more for the chosen technical solution than is needed. You could, because good planning and estimating is not done, you could have to spend a lot of money on the backside doing commissioning and startup with very expensive resources, on per diem, and I mean it could really get astronomically. You remember the curve that Nick showed earlier with the kind of the exponential curve as it gets closer to the end of what changes can cost you. And so again, the purpose of good FEL is to minimize the surprises, so to speak, that can cost a lot of money. So while good FEL can produce good savings, poor or no FEL can result in much more significant cost overruns later in the project.
Larry asked another question. Is the increased focus on FEL going hand in hand with a MAC approach?
Yeah, I can start on that one. It's Matt again. I would say what we would recommend, even collectively, the three of us, would be doing optimized, kind of best-in-class FEL, whether or not you're doing a MAC approach. And for folks on the call, MAC meaning main automation contractor. There's different terminology, but basically going through a fairly robust selection process and picking one supplier of automation and control engineering services and potentially platform, and kind of single sourcing that supplier to do all your control system work. And so I guess the short answer is the benefits of doing good FEL are going to be there whether you do a MAC approach or not. Potentially, and really they ought to be, not just potentially, they ought to be even better with a MAC approach, because as you work with the same supplier over and over again at different plants, or even within one plant, and as you refine how you go about that FEL process, refine the tools, refine the processes, get more and more efficient at it by working with that same contractor, you should, FEL should get more and more efficient, and the quality and consistency should get better and better over time. And you could see how if you're working with 3 or 4 different suppliers, you're not going to quite get that efficiency gain you could with working with just one supplier. Now, of course, that means you need to work with a good supplier that's very competent and equally focused on good front-end engineering. So I would say good FEL no matter what, and if you do it with a MAC, it's potentially even better.
All right. Sharon asks, how do you work with the folks on the plant floor to accept and use the new systems to gain the process improvements and cost savings submitted in the project?
Well, this is Charlie. I'll jump in. I mean, many of the examples that were given as either new areas or innovation areas or value-improving practices, things like facilitated graphics discussions, S88 optimization. In our experience, those activities they're not something that controls engineers do in a dark room, where nobody gets in. It's actually an interactive process that you have to be effective. You have to facilitate it with the plant floor folks, with the operations folks, and they're actually engaged in those planning and decision-making activities. And then after that's done, then the rest of the configuration can happen pretty methodically. But I would say it's absolutely essential to have their involvement early on. I mean, some of these things are radically different, especially if you're moving from a 20-year-old system. Many of these things look very different, but they also perform in a much higher way. And the simulation capabilities available today can also let you, on a small scale, demonstrate some of that and get people aligned. So it's easy to do, but it does require early engagement.
And this, Nick, I'll add on to that. I think it's an important step, especially if you're introducing new technology. It's actually on a project years ago where we put in Field Bus, and 3 years later we took the Field Bus out because we hadn't made the transition of our workforce, of our maintenance organization, to be able to support that Field Bus. Part of that is having enough of an installation base that people will learn the skills and be able to practice the skills. So I think you do have to put a lot of thought into, well, what's your training program, and how are you going to be able to make sure you've developed new skills and the folks that are going to maintain and operate that. So, it turns out that that's probably not as much as a front-end loading and even the project design as the operations organization typically has to think about their aspect of it too, the whole portion of that, thinking around the capability of the people that are operating the facility and staffing and those kind of things that kind of typically will fall outside of the design aspect. But still an important aspect.
Okay. Sharon asks an additional question here. Are the new systems user-friendly or require long learning curves that might prevent their adoption by the people on the shop floor? And how do you address this in the FEL?
Well, this is Charlie. I'll jump in, and Matt and Nick can comment. But I mean, I would say, generally speaking, a more modern system is going to be seen as slightly more user-friendly than a system that's much older. But depending on the platform, some are simpler than others, and some have longer learning curves. So when we talk about this platform comparison and the development of those TIC and TCO estimates, I mean, we would include a weighted factor based on experience and feedback, how much time is required for deployment, how much time is required for training, and make sure that the relative cost to do that are appropriately accounted for on each platform, so that the total cost by platform, as opposed to just throwing in placeholders across the board.
This is Nick. I'll add a little. Are the new systems user-friendly? The new systems are complicated in terms of maintenance, and the operations standpoint, we typically try to make them pretty user-friendly. But at least in my experience, there's so much layering of software. There's a different software package for this and software package for that, and it's a server and another communication. And it really does the support and continuing to be able to make let's say you have a software application that's trying to maintain, bring in all your heart signals and tell you about the health of your instruments. Those software packages are really not that user-friendly to operate. There's a lot of complexity into those. They're tying into a server to get data, and the connections fail sometimes. There's a lot behind those kind of things, and you need to have somebody that's got develops a certain level of capability in there to be able to keep that working and help all the rest of the people in the organization who just need to use it. And so there's some user-friendly aspects to it, but there's some complexity too.
All right. Next question asks, what is the most effective hazard analysis?
I'll go ahead and try. It really depends on what kind of hazards do you have. If you're talking about, we would typically do a process hazards analysis, a PHA, and with that PHA, we would identify if there's hazards of special concern. We might do a layer protection analysis, and if the risk was really significant, if the potential to kill a lot of people in the community, an incident, then we would probably do some detailed consequence analysis and fault tree work. So really I think that the best technique goes with, well, how well do you have to understand that the higher the potential risk of the hazards, the more detail you need to put into that analysis to make sure that your protection is adequate. For more information around hazards analysis and those kind of things, I'd direct you to CCPS, the Center for Chemical Process Safety, part of the AICHE, American Institute of Chemical Engineers. So just go online and Google CCPS. There's some very good books there on, and also training classes related to hazards analysis.
Okay, the next question comes from Peter, and he asks, what is an example of high-performance graphics?
Charlie, you want to handle that one? I'll probably do that.
Yeah, I'll take a stab at it. I mean, again, I think when we talk about high-performance graphics in this presentation, that's known as many things. I mean, there's human factors, human-centered designs. There's, the group, the ASM Consortium, is really published more information on this than others. But if you look at those graphics, subjectively, I mean, this is the grayscale, color is by exception type of graphic. But, I mean, the characteristics of those that are very common is that information is presented to the operator by exception only. So color is used to draw action. And the inherently high-performance graphics are layered. So, and then once you get the layering right, navigation between the different graphics and layers becomes more important, and the ability to summarize alarms up so that, again, the operator's attention is drawn to where he needs to take action, both on the current graphic as well as some ability to see where they need to navigate to in the graphics system to get to where they need to take the action. I mean, I don't know if that answers the question exactly, but that's the best short answer.
Great, moving on. Next question says, who should do the FEL study? The company, consultant firm, or vendor before the signed contract?
Yeah, I can take a stab at that, this Matt. And the general answer I would give is the party or parties that have the experience and the tools and the processes to do it effectively to achieve the goals of the FEL process. So it should be that whoever's most qualified and cost effective to do that. In our experience, again, often what we've seen is that high-level initial FEL work is often done internally by the company. So FEL 1, FEL 0 level work typically don't need to engage any help. Another factor in this is what are the capabilities of the company, the end user? Do they have a fairly, large, robust, qualified, experienced controls group? Some companies have held on to those and still have fairly large groups of controls engineers and project engineers project managers to do some of that. In other cases, as many of y'all know, those groups have been minimized, through retirement and just the economic downturns and other things that have happened over the last 10 to 15 years. What once were 10 to 12 person controls groups are now down to a few people, maintaining the system, keeping it running. And so that's a variable, is what really, what are the capabilities that you have internally to do it. And so, oftentimes people are getting outside help to do this kind of work. And so, again, I would just kind of commend who has the requisite qualifications to do that work, the tools, the experience. And one really important caveat is if you're at the FEL2 stage and you're comparing solutions or platforms of competitors, and we do recommend that, then you can't use one of the vendors to do the FEL work. There's a kind of an inherent conflict of interest. And so, at the FEL2 stage at least, you need to engage a third party that is independent, that doesn't, quote, have a dog in the fight, and that will help you gather objective data to do that decision. And oftentimes and we recommend that FEL work ought to be done collaboratively. It's, as Charlie mentioned, it's not like let's gather all the documents and then go back to our cave and in 6 months we'll give you a recommendation. It should be done very collaboratively from the beginning, including operations, engineering, maintenance, and then any outside resources you may use, so that it's done again in a very collaborative fashion. And that would be the thing I would recommend.
Okay. Next question is, how is the FEL rating calculated?
Yeah, I think for that I would refer the question really to that IPA website, and there's some description of how it's calculated there. The short answer is that it really is based on deliverables that are able to be demonstrated from the specific list. So a lot of times, folks aren't willing to invest in the time or effort to generate the deliverables, and then you wouldn't get credit. That would drive the score down. And the whole spirit of this is it's based on generating deliverables to feed that further process. And then looking back at Nick's earlier graph, when you get to that point of the curve where the cost to change is more significant and more commitments have been made, you want to make sure everything is properly documented, or it's very difficult to share with a number of people to get involved.
Okay. This next question asks, when a vendor makes a proposal price / contract with FEL level, should he be? Prices are fixed for vendor, but the re-engineering had to start after the signed contract.
I mean, we see this all the time. I think again, the answer to the question isn't meant to be flippant, but it really is a function of how much risk you're willing to take on as an owner in implementation. So you can commit to a contract at a relatively low FEL level if you're willing to take on the risk that goes with that. I would say and most people tend to want to get to that plus or minus 10% type cost issue and a pretty definitive schedule. That's going to require FEL3 level quality. I don't know, Matt or Nick, if you have additional comments.
Nothing here.
No, I wouldn't add. I mean, again, I think I hate to keep beating the drum, but if you look at the kind of the overall purpose of FEL2 in the grand scheme of things, it's to get the cost and technical data together to analyze solutions and then make a choice. I don't think we would generally recommend making a technology choice until you, quote, done your homework, and then go through final negotiations with either your preferred vendor or solution, or if you've narrowed it down to two, go through final negotiations with those two, and then make a contractual decision. And then obviously that saves you money and upfront costs, but also re-engineering, and then complete, based on that platform selection, then complete the rest of the engineering based on that.
Right, I know we're getting short on time, so we'll try to make these last few questions brief. Next question from Carlos says, It seems FEL is a term more applicable in brownfield projects, while greenfield is really part of the feasibility studies and typical planning process. It seems FEL is more valuable because reverse engineering / planning. Would you agree?
I mean, I would say they're not as stated. No, I mean, I think brownfield or greenfield, good FEL practices will have a benefit. Again, I think it's a matter of terms. Sometimes what people call them, whether it be feasibility and basic engineering, extended engineering, you just have to do the coordinate translation. But I mean, to the last point, I think it's absolutely true that if there is a reverse engineering phase involved, the more upfront work is going to have a much greater benefit.
Next question. Highly transactional customers don't see a lot of value in early FEL. How do you overcome this barrier? Promise of future saving is not real money for those customers.
That can happen, and I think my suggestion would be to just try to do everything possible to provide the basis and the background. And again, at the end of the day, if a particular person doesn't see the value in the risk reduction that you get, then I think that's an owner's call. And if they carry the risk forward, then they'll pay the consequences.
Okay, next question. Can FEL be used for a partial PLC migration in a plant? And are all FEL phases needed in every migration project?
Yeah, that's a great question. We actually get that fairly often. Overall, I would say, yeah, FEL could be used for a PLC migration. Now, let's say, for example, we're talking 8 to 10 PLCs. I would say my general recommendation would be to perhaps do an abbreviated or, more concise FEL process, and we're involved in those kind of efforts where it's kind of a combination FEL2, FEL3, and we're doing the requisite planning and other tasks, but you don't need to do it to the extent you might for a 30,000 point DCS migration. So the general principle being, let's keep the end goal in mind and do the requisite upfront planning and estimating that's necessary for a successful project that delivers value. So you want to be flexible in the FEL process. It's part of the reason I didn't present, for each stage every deliverable, because there should be the overall goal should be the same, but there should be flexibility in how that's done and what the deliverables are and that kind of thing. But some front-end engineering and front-end planning and front-end loading is essential for any control project migration. You will save money by doing that, putting that blueprint together up front.
Okay, next question. What would be the justification for migration and the ROI of moving to a newer system as long as the old system is reliable and performing?
Yeah, that's a great question. So if we take, for example, the old system, and we run into this a lot, the old system is reliable and performing. The question, and a big reason DCS migrations, for instance, are justified is based on reliability and obsolescence. While those systems have probably been reasonably reliable and performed well for their lifespan up to now, there are more than one DCS that are not just approaching but have entered obsolescence status, meaning it will become increasingly expensive to get spare parts, to get people that know those old systems to service them and to maintain those systems for any long-term length of time. One of the things we've done when we do a TCO at the FEL2 stage, so total cost of ownership, is we may analyze platform X and platform Y and platform Z. But what we'll also do is do a TCO for maintaining the existing platform, which for the next couple of years may be less or roughly the same as a new platform. Because again, you can keep using whatever spare parts you might have, but 5-10 years out, it becomes astronomically more expensive to maintain that old system, because you'll be buying spare parts of eBay or some other third party. The engineering resources that know those old systems are going to become more and more harder and harder to find, and they're going to be increasingly expensive because of supply demand. And so, you may be able to, quote unquote, kick the can down the road for a year or two, but not forever. And as you delay that migration, the total cost of ownership of the existing system begins to increase exponentially. And there will come a time when buying spare parts for some of these obsolete systems off of third parties, eBay, whatever, will be extremely expensive and even unattainable, where you need an I/O card or a processor or a power supply, and you simply can't find it, and you've had a failure in the system and you have no spare parts. Then the cost of downtime is potentially astronomical. So.
All right, great. We got 2 more questions here, and we'll wrap it up real fast. This one comes from Derek, and he asks, where can one find a good TCO template for DCS migration?
That may be a trick question. I would just say there are, just to be honest, I mean, as Maverick, we have some pretty good templates. I'm sure there are others out there. One interesting note is TCO in our times and our days is kind of in the eye of the beholder. And so when we sit down and talk TCO, we kind of define the term and kind of go through it in detail and make sure we're in agreement about what's in, what's out, what it is, what it isn't. And, again, trying to avoid the whole crystal ball type of approach and have foundation for the numbers. And so, again, we have a template for doing that. I don't know, Charlie or Nick, if there are any kind of, if IPA or anybody else has any templates for TCO.
Well, again, I think, like you say, you could Google TCO and probably find some templates. I think, some of the ones we have are very, very customized in the migration space or automation implementation space. So, again, I think it depends on how general of an answer you can live with or how specific you want.
Okay. Last question here from Jennifer. If you are migrating an existing system, do you call a cutoff date during the FEL for no more changes to the existing system? And when is the best time to call a no more changes to the old system?
I mean, I would just offer on this one, it depends on the customer and what the business needs are. So what's probably most important is that there be a very clear management of change process documented for the project. And that could be as simple as at some point you just declare no more changes. It could also be that you just very rigorously keep track of and manage those changes so that you don't lose them at the end of the day. But for sure, it's a risk that you're introducing into a project if you're going to keep changing the existing system as you're trying to migrate it or modify it.
Yeah, this is Nick. I'll just add to that. Depends on the types of changes. If you've got an existing system and you have something that is safety related, you will go make those changes. It may satisfy a customer need for a current campaign. You'll make those changes, and you'll just have to have that right change management procedure to make sure that those are incorporated in the new design. But continuing to make design basis changes and in the project, that's where I've seen the greater risk. So. But change management's a critical part of doing a project like that.
Yeah. And in fact, it's part of FEL, particularly like in the FEL 3 stage, you would want to go ahead and define what your change management procedure and process looks like before you start the project. Michaela also wanted to just kind of append my answer from earlier about cost of FEL 2 and 3 and kind of what the factors are that can affect that. We kind of talked about the 6 to 10%. Remember that one important factor to remember in all that is the quality of the existing documentation is a huge factor in determining how that level of effort. And we've kind of run across all variations of that. So if the PIDs, loop sheets, actual program documentation, panel documentation of the existing system cabinets and I/O. So the better that existing documentation is, the better it's maintained. If it's in electronic format, all the better. The better that documentation is, you can potentially minimize the FEL cost. If that documentation is in poor shape and hasn't been well maintained for the last several years and it's pretty out of date, and there's going to have to be a reconciliation and remediation effort to bring the documentation up to snuff. Maybe not everything, but the essential documentation like PIDs, then that could add to the FEL cost if you have to do that as part of the FEL effort.
All right. Thank you, everybody that participated in today's webinar and in the Q&A session, and for our presenters, thank you. If you missed any portion of this webinar, or if you would like to watch the recorded version, we will be emailing all registrants a link to the recording along with additional links for supporting information, including the presenter's contact information. So if you have other questions for them, you can contact them directly. So be on the lookout from an email from me in the next couple of days. Additionally, once you close out of this webinar, a screen should pop up in your browser for you to take a short survey for us. Just take 1 or 2 minutes to tell us a little bit about your experience with us today so we can better improve our webinars. And I think that's about it. This concludes the front-end loading for Control System Migration webinar. Thank you all for attending, and we hope you acquired useful information. I hope to see you again in one of our future webinars.